And now for our second part into colors. Welcome to Mars. Yes, this is one of the first photographs Earth got of Mars. If you notice something, notice how none of these photos are in color? That's right, because when the first photos were taken of Mars, they were all taken in black and white. And you could say, well, wait. In my textbook, I saw photos like this one, Mr. Farrell. So how in the world is it possible that all the photos were in black and white? Lies! Actually, what happened here was the photos were all in black and white, and they recolorized the photos afterwards. They determined what kind of iron oxidation was on the ground or in the atmosphere that caused the red tint to the planet when we looked out on the outside. But a lot of the recoloring was done by artists, based upon the highest science of the time. But certainly, Mr. Farrell, they've got to be using color photography now. And yes, they are. In fact, we're going to play a little game called Earth or Mars. Well, we're going to look at a photo, and you'll have to guess whether or not it's from Earth or Mars. So put down a letter, and by each letter, you're going to write down if you think it's Earth or Mars. So write down whether you think the letter A is Earth or Mars. Is the letter B Earth or Mars? Is this Earth or Mars? And I hope you did well on our game show. Was it as easy as you expected it to be, or was it harder? I know a lot of these things are a little bit trickier than you probably imagined. I mean, Earth and Mars really look a lot alike. So after your head is done exploding, let's recuperate and make it hurt even more. Ah, this photo, one of the most majestic photos of space ever. Mr. Farrell, don't tell me it's not real. Please don't tell me it's not real. I'm not saying that's not real, but there's a heck of a lot of Photoshop going on in here. Those colors, how they do this is they sample what colors would be in that nebula and go, those colors would be sampled by what gases. And we know that gases emit certain colors. For example, iron oxidation, let's go back to that, is red. How do we know that? Because iron oxidation is rust. Basically, it looks like Mars is rusting, which is why they know that the planet's red, because it's got a lot of those chemicals on it. Just like in the atmosphere of this nebula. There's an atmosphere in a nebula? Yes, because it's emitting gases. Those gases are going to have certain colors. Beautiful, right? I know, right? Yeah, the artist should be given a little credit here with the scientists coming up with these colors for this place. Does that mean that this isn't scientifically accurate? No, not at all. In fact, we're using the best science we can to be as accurate as we can, which is what they were originally trying to do with Mars. But as we got closer, the accuracy changed, because we know that, okay, now we're actually there. It's a little different. It's like looking at somebody from a distance. You're like, whoa, look at that person. Then you get up closer, you're like, oh, look at that person. The reason this is so awesome is I know part of you is probably going, I've been lied to, but you haven't been. They're doing the best they can to be as honest as they possibly can with what they know. But if anything, this should encourage us to explore more, to know more, because we only have part of the story. And as we get closer and closer, the story unveils itself to be something spectacular. Like, this kind of looks like the Eye of Sauron from Lord of the Rings. All right, what are they actually seeing? Well, this is what scientists actually see. This is information taken from the Hubble Space Telescope. And they've improved the cameras, and they've improved the resolutions, and they can process this, but this is what an actual raw photo looks like from the telescope. And then they enhance it. One of the key ways that they do this is they take color theory, the stuff that you're learning right now, to be as accurate as possible. Because there's certain rules to color that you've already been learning, and then you're going to learn a little bit more about today. So let's explain those tricky colors through the color theory basics. On your left, you see the color wheel that you're familiar with, spinning around and around almost like a game show. See, there's a theme going on here, huh? On your right, we still see a color wheel, but we see this triangle. And this triangle is linking the primary colors of the physical world. And what does that mean? That the reason they're called primary colors is that you can't mix anything in the physical world to create a yellow. In the world of light, you can, but not in the physical world. You can't mix anything to create a red or a blue. However, you can use red, blue, and yellow to make almost any other color. So you see here, these are the secondary colors. If I took yellow and blue, which are primary colors, and mix them together, I will get green. If I took red and blue, I might get violet or purple. Or if I took yellow and red, I will get orange. Now, complementary colors are colors that help each other stand out. And the reason they help each other stand out is because they are the exact opposite from one another, which is ironic that red and green are complements. But so are orange and blue. A lot of sports teams use complementary colors because it grabs our attention. It's kind of like that phrase, opposites attract. Well, opposites attract our attention. They don't necessarily attract each other, but they attract people's attention. Like, whoa, those two things should go together. Let's look. And we do. Analogous colors are those colors that all hang out together because they're similar. Like red, yellow, and orange all seem to be similar, so they're going to hang out together. Kind of like band kids, we're all playing in the band. So let's all hang out together. Art kids do it too. Everyone, if you find an interest that you're similar or like, you hang out. Like, oh my God, let's hang out because we talk like this. Oh my God, you're so right. I know what you're thinking. Is he ever going to get the black and white? He promised he would. He said they're not really colors. They're a shade or a tint. This is a shade. Notice the color is getting darker. You say, well, Mr. Farrell, that's because there's value in it. Right. But what exactly is black? In the physical world, it's the combination of all color. It's everything slapped together. And I could give you this long process on how to do it. But guess what? I'm not going to. I have a simple formula for you. Color plus black plus color equals shade. Now, what do you mean by that, Mr. Farrell? What it means is I'm going to put color down solid. Then I'm going to add a little bit of black, and then I'm going to put the color right back over it. I'm going to create layers, and that's going to create better shading for the color tones. But what about white, Mr. Farrell? You didn't bring up white yet. Great question. White is either the combination of all colors in light or the absence of all color, which means it's in the physical world. It is an achromatic color, which means it's not really a color, it's a tint. You go, well, how do you make it? Like if you're making paint, why is there white paint or white colored pencils, Mr. Farrell? Because of its achromaticness. It's not in the color wheel, okay? And how they make it is they completely desaturate the pigments. They take all the color out of the pigments and then you have white. So there's nothing there as far as saturation. And again, I can go into a long drawn out process on how to create a tint. Guess what? I won't. Instead, I want you to start off with this simple formula. Color plus white equals tint. How you do this is you start to put the color down and then you ease off the gas pedals, ease off the pressure of the color, and simply get lighter and lighter and lighter. Then what you do is you go back over it with the white to help smooth it out. We call this burnishing. We use this in color pencils all the time. But we do it in other media as well to help smooth out the color. And again, that creates that beautiful tint where it looks like that red goes from red to being a pink to almost bright white. We're almost done with our color adventure. As you see, as we're going through with this, we have just a few more things to go, and then we'll pretty much understand the very basics of color. Like complementary colors. I told you that sports teams often use them. If you look at the colors on the left, you're going to see that the orange and the blue are actually kind of fighting against each other. They have equal dominance. But if you look at the colors on the right, they've picked a dominant color. And that orange acts as an accent, right? And a little bit helps pop against that darker background. By playing with color intensity and saturation, you really can push things back and bring things forward. We talked about this a little bit earlier in the year when we talked about atmospheric perspective. And this is a warm color scheme using that same concept. I know a lot of this color theory seems overwhelming and scary at first, but with a little bit of practice, you will understand and get it. You got this. I'm Farrell, and this has been a Braden River High School art production.